In this submodule, we start with a more detailed explanation regarding the network configuration file. It uses YAML to describe the components of the quantum network that you will be simulating. In the submodule, I will explain in more detail the config.yaml file that describes the network configuration. The network configuration consists of stacks, links, and C-links. Stacks are the end nodes and got their name as stacks due to being a combination of the quantum device, the host component that is running the program, and the classical control software layer that controls the quantum device. Links represent the quantum connections between the various nodes, and they are used to generate entanglement between the Alice and Bob node. And C-links represent the classical connections and are used to send classical messages between nodes. Then stacks have various parameters. The first parameter is the name parameter. This describes the name of this node, and this name is being used on multiple places. For example, we use this name in order to declare that the Alice and Bob node are linked to each other via classical and quantum links. But we also use the name to assign the quantum programs that we want to run to the Alice node, and also to retrieve the correct sockets. For example, in the Bob program, we would specify that we want to have classical sockets to Alice for it to perform its program. Then the next parameter it has is the Q-device type. This specifies the model of this quantum device. In this case, we're using the generic model. The generic model has the major components of noise, but doesn't really have any peculiarities in regards to how these noise models behave. A different example would be the nitrogen vacancy model. This has some special peculiarities, special behavior regarding to how its topology is structured. It has, for example, the topology that only the carbon and electron qubits can interact with each other. Then we have the Q-device config. This uses a special feature of YAML called anchors. These anchors are used to copy this shared generic Q-device config to both over here, Alice and Bob. We declare this shared generic Q-device config over here, and normally you would have all of these parameters directly specified over here, but we don't want to clog our screen with duplicate information, so we declare it just one time over here. The Q-device configuration has various settings. For example, we can specify how many qubits are available on our device. We can specify the coherence times, so both the longitudinal and transverse coherence times. These are in nanoseconds. Then we can specify how long each of the operations take. This again is in nanoseconds. So for example, over here, it specifies that initialization of a qubit takes 10,000 nanoseconds. Lastly, we have the noise models. These specify what the chance is of depolarizing when we perform a gate. In this case, we apply a 1% chance of a qubit depolarizing when we perform a single qubit gate, and a 10% chance of depolarizing when we perform a 2-qubit gate. Next up are the links. So these are the links that you use to generate entanglement between Alice and Bob. So you specify which two nodes you connect via the stack 1 and stack 2 parameters. Then you again specify the model type that you're using via this type. The depolarized model is, after the perfect, one of the first and most simplest models that does allow for noise in comparison to the perfect model. There's also more advanced models available, like heralded models. But the depolarized model, it has a few sources of noise, has the fidelity as a source of noise. This specifies the fidelity that entangled qubits that are generated using this link have. Then you can specify the T-cycle time. This specifies how long each entanglement attempt takes in nanoseconds. And then the probability of success that specifies what is the chance that each of these previous entanglement attempts succeeds. Lastly, we have the C-links. These specify the classical communication. Again, we have to note which two nodes we are connecting, then which model we're using. The default model is one where we allow for deterministic classical communication, where the communication always arrives at a fixed 100 nanoseconds after it has been sent out at the previous node. Then, in order to create networks that have more than 2 qubits, you would have to add more nodes and more links to connect them however you like. We also have many more models available. You can find these models on the SquidAsm Read the Docs page under the API documentation. And then this concludes the network configuration submodule, and I will see you in the next submodule about input and output.